Uh, can you share on my WhatsApp the link of this live sharing, the Facebook link?
Yes, sir. I will share.
Please do. Thank you. So did you share with me the Facebook link?
Yes, sir. I will share.
Okay, I got it. All right, so should we start?
Yes, sir.
Okay, right.
Welcome everyone present here virtually. I am Nalini here and I welcome you all for today's session, which is titled as Data Analysis in PLS-SEM via Smart PLS. And presenting this session, we have with us our today's expert, Dr. Syed Muhammad Fahim. Dr. Syed Muhammad Fahim is an assistant professor in the Department of Marketing at the Institute of Business Management, Karachi, Pakistan. He has extensive experience in the field of research and marketing with more than 35 research papers at his credit. He has developed specialized skill in partialist square structure equation modeling, SEM, and obtained customized training from abroad. He has conducted training at different national and international universities. His forte is partialist square structural equation modeling via Smart PLS. He is consistently involved in attending and conducting workshops on PLS SEM via Smart PLS at various national and international forums. You can start now, sir.
Okay, thank you. My brief introduction has already been given, so let me start directly with the topic. Today, I'm going to talk about data analysis in PLS-SEM via Smart PLS. At this point in time, let me clarify. PLS-SEM is partial least square structural equation modeling. This is the statistical technique. The name of the technique is PLS-SEM, partial least squares statistical equation modeling. Smart PLS is not a technique, it's a software using this technique. There are other softwares as well, like there is a Danco, there is forte PLS. So there are other softwares as well, but definitely this software, Smart PLS, this has gained more popularity because of its versatility, easy to use, user-friendly interface, and consistent developments, bringing in by the developers. So today I'm going to talk about how we can perform the basic analysis in PLS-SEM via Smart PLS. Before I move on to the software, let me show you a few things here first. All right, so I hope if at all we can see on the screen, there is a basic regression equation.
Yes.
Right, so this basic regression equation says that y is the dependent variable, right? A is constant, b is the intercept or slope, x is the independent variable, and finally by the end it's the error term. This equation has just one dependent variable and one independent variable. The name of the dependent variable is y and independent variable is x, right? Beta is the slope, right? How much change occurs in x, then as a result, how much change will occur in y. This is called beta. Suppose this is 0.3, it means it means a 30%, 100% change in x will bring a 30% change in y. So beta is the slope, rate of change. If I try to extend this equation, and if I try to add one more independent variable, name say x2, then the equation would be like y is equal to a plus b1 x1. x1 is the first independent variable, x2 is the next independent variable, and so on and so forth. But I hope we all can see it very clearly that this equation still has, although so many independent variables, x1, x2, x3, xn, any number, but still there is just one dependent variable. In real life situations, it is not necessary that in regression, while we are running a regression, there is only just one dependent variable. There may be 1, 2, 3, 4, or any number of dependent variables is possible. So suppose if there are two dependent variables, then definitely we have to add one more equation to it, right? We cannot add another dependent variable in the same equation. For having another dependent variable, say y1 or y2, we have to add another equation. And if there is a third dependent variable, then there will be third equation. If there are, say, 10 dependent variables, then there will be 10 equations. So the beauty of statistical equation modeling is that it can model different equations together simultaneously. That is why it is called structural equation modeling. There are basically two types of techniques in statistical equation modeling. One is called covariance-based SEM. I hope you all must have heard about MOS. MOS is a software which utilizes the technique of covariance-based SEM. The Smart PLS is basically a technique which utilizes is basically a software which utilizes the technique of PLS-SEM. So PLS-SEM is variance-based, and covariance-based is another domain. When SEM was introduced way back in 1970s, rather, so I mean, covariance-based softwares, they were in more popularity, like the initiators for Lizerl, there is MOS, there is M+. These are all covariance-based softwares. But when this decade of 2000 started, PLS-SEM started gaining its momentum, its importance, and it has started ruling the scene. So I have seen in majority of the marketing and management research papers, very good journals, they are accepting papers more on which the data is analyzed via PLS-SEM. Now the question arises, why PLS-SEM, why variance-based SEM, why not covariance-based SEM? The answer is simple. If the distribution of data is non-normal, then we have to go for PLS-SEM, right? So PLS-SEM is basically a technique which actually caters in such situations where the data distribution is not normal, that is non-parametric. Second important advantage of PLS-SEM is that if in the model formative constructs are involved, then covariance-based SEM is unable to handle formative constructs. Formative constructs can only be modeled and handled and analyzed with the help of PLS-SEM. So these are the two important characteristics. Few people claim that even if the data size is small, we can use PLS-SEM, but this logic or this argument, it has lost its importance in the recent research. So finally, I could say that PLS-SEM is advantageous to use if the data is non-normal and if there are formative constructs in the model. I'll be discussing in a while what formative constructs are. So let me go to the software now. This is the user interface of the software, right? This is a licensed software. This licensed software is basically you can buy it from the website of SmartPLS, and I am sharing with the organizers the license, the 2 months free license key, and I hope that would be of help to you all, and you can utilize this license key for 2 months, and definitely after that you need to purchase it, right? So this is the user interface, right? This blank white canvas, this is the place where model is to be drawn. On the left hand side, the top side is Project Explorer, and at the bottom there is an indicator panel. First of all, what we need to do, we need to create a new project over here. We can write the name of the project, like say I'm creating a project in my own name. So suppose I'm creating a project in the name of Research Circle. So a project is created. I hope we all can see that in the Project Explorer panel towards the left hand side, there is a project created in the name of Research Circle. Beneath this title, this project of Research Circle, there are 2 tabs. One tab says double click to import data. It means first of all, we need to attach that data file. Since it is quantitative data analysis, so we must have collected data. Nowadays, data is collected via Google form. So there is an option in the Google form which says that we can download all of the responses in Excel format. So what we need to do, we need to download all of the responses in Excel format, and we need to save that file in a particular format called CSV, delimited. So once that file is ready, the data file is ready, then we can attach this data file over here, right? So first of all, we need to attach the data file. Once the data file is attached over here, then this Research Circle, once we press it, this white canvas would appear, and then we need to draw our model, our conceptual model, our size model in it. So there are 2 steps. Step 1, create the project. Step 2, import the data file. And step 3 is draw the model. Once all these 3 steps are finished, then we can start the data analysis. So let me take you to an already made project. So This is suppose the data file, corporate reputation data, 344 records. It means there are 344 respondents or cases in this file. So this is the data file attached. Let me repeat, this file, it has to be in CSV, delimited format. It's easy. Once we download the file, even in Excel format, the extension of Excel files is .xls. Then we just need to go to save as and change the extension to CSV format, and then we can save it, and then we can attach that CSV file over here. So it's easy, it's just on a click. We need to change the extension, and then we can save an XLS file into CSV file, and then we can attach this file over here. So this is the file, okay? You can see. Once a file is attached, these statistics will appear automatically, like mean, value, median, mean, maximum, skewness, standard deviation, excess kurtosis, skewness, etc. This is called descriptive statistics. Descriptive statistics would appear automatically as soon as we attach the file, right? Once the file is attached, then we need to definitely draw the model. The drawn models would be somewhat like this. This is an already built up model, just for the sake of saving the time, because we are not having that much time with us. So what I will do, I will erase this model, I will redraw it again so that we all can learn how to draw the model. So once the file is attached, then we need to draw this model. Actually, this model is nothing, it's just a replica of that already drawn model at the end of literature review. See, the outcome of the literature review is this conceptual model in any of the quantitative studies. So this model says that there are 1, 2, 3, 4, 5 constructs, or 5 variables are there. The name of the first construct is comp. This is an abbreviation of competence. The second construct is like, is an abbreviation of likability. CUSA is customer satisfaction. CUSL is customer loyalty. ATTR is attractiveness, right? ATTR is actually the moderating term or the interaction term we have generated once we've attached this ATTR as a moderator. So in this model, there are 2 independent variables, 1 mediator, right? 2 independent variables are competence and likability. The mediator is customer satisfaction. The dependent variable is customer loyalty, and the moderating variable is attractiveness. And this moderating variable actually moderates the relationship between likability and customer loyalty, right? So this is the model, right? Now you may ask me how to draw this model. So it's easy to draw this model. Let me make a duplicate of it. I have made a duplicate of it so that I can erase it and I can redraw this model, right? So that we all can learn how to draw the model. This is a duplicate, okay? So let me erase all of it, right? And I will redraw it so that we all can learn how to draw the model. Let me repeat, first of all, we need to attach the data file in CSV, delimited format, and then we need to draw the model. The model is very simple. It is a replica of that model which we had already drawn at the time when we were developing our conceptual framework at the end of literature review. So I hope we all can see in the indicators panel towards the left-hand side at the bottom, there are 3 indicators of COM, COM1, COM2, COM2. Indicator means questions or items. So I have just selected all these 3. I need to drag and I need to drop them over here. So it's very easy, just drag and drop, right? I need to change the name of this variable to com, C-O-M, com. So I have drawn the first construct or the first variable of com. Now the second independent variable is like, L-I-K-E, likability. I need to change the name of it again, right click, rename, L-I-K-E, like. Then there is customer satisfaction in the middle. It's a single item construct. Single item constructs are actually not very common in research, but PLS-SEM is having the unique capability of even modeling those constructs which are having just one question. In MOS, it is not possible. In covariance-based SEM, if a construct is having just one indicator, one item, or one question, it would give error, right? So another beauty or another plus point of PLS-SEM is we can run the model even if the construct is just one item construct, that single item construct. I need to change it. The name of it is CUSA. Then comes customer loyalty, the dependent variable. So customer loyalty is the dependent variable. What I can do, I can change the direction of the indicators. Indicators towards right. Okay, then I need to connect. Still the model is incomplete. I need to add one moderator to it. Okay, so the name of the moderator is say ATTR, attractiveness. There are three indicators to it. This is ATTR, attractiveness. Now, this is the moderator. In Smart PLS, this moderator we must be knowing by virtue of theory or by virtue of already reading the literature, that suppose this attractiveness, it moderates the relationship between likability and say this customer loyalty, CUSL. So what I'm assuming that I have established this relationship that attractiveness moderates the relationship between likability and customer loyalty by virtue of literature, right? By reading the literature. So in PLS, we need to connect it only to the dependent variable, that is customer loyalty. Still, the moderator has not formed. If we really want to create the moderator now, so I need to go to the moderating effect, press it, moderating effect, bring the cursor to the dependent variable. A window will open, and this window would say that the dependent variable is customer loyalty, and it is asking you what is the name of the moderator variable. It's a drop-down menu. I'm selecting ATTR as the moderator variable, and it is asking again what is the name of the independent variable. I'm saying say likability is the independent variable. No further changes are required. Press OK. So I have created an interaction term now. This interaction term is actually the moderating effect. Okay. But definitely this moderating effect can never be created unless we have introduced ATTR in the model already. So this ATTR alone is nothing. It is at the moment acting as a independent variable as com and like are operating. But as soon as we introduce this moderating effect, now we let the software to understand that this ATTR is the moderating variable in between like and CUSL. There is a particular nomenclature of it. See, if I place my cursor on it, it says the dependent variable is CUSL, moderator is the ATTR, independent variable is like. Okay, I need to change the name of it. The technique of writing the name is, first of all, write down the name of the independent variable, that is like, multiplied by, that is asterisk, the name of the moderator, ATTR. So here it is, the interaction term. Moderation is actually another name of interaction term. Interaction term means if ATTR interacts with likability, what could be the combined effect of ATTR and likability on CUSL? That is why it is called interaction term or moderating term. So I have drawn the model now, and it is similar as I have shown the model originally. So the model is drawn, the data file has been attached, and now we are ready to run the analysis. So let me repeat. First of all, we need to create a project, then we need to attach the data file, and then we need to draw the model. Model will not come from somewhere else. It is actually the replica of that conceptual model which we had already drawn at the time of literature review. So now the analysis would start. This analysis is actually divided in two segments. The first segment is called measurement model, and the second segment is called structural model. I'm repeating. The analysis or the basic analysis is actually divided into two parts or two segments. The first segment is called measurement model, and the second segment is called structural model. In the measurement model, we try to make ourselves believe that all these constructs in this model, they are reliable and they are valid. Once we are very much sure about the reliability and validity of all these constructs, only then we can run the structural relationship or test the hypothesis. So testing the hypothesis or running the structural relationship is a secondary stage. It will come later. First of all, we need to make it sure that these constructs, they are valid and reliable. And once we are checking the reliability and validity of these constructs, actually we are running the measurement model. So measurement model is another name of checking the reliability and validity of these constructs. So first of all, we need to run the measurement model. And once the reliability and validity will be established, then we'll be running the structural model, that is testing the structural relationship, the relationship among these constructs, between these constructs, that is testing the hypothesis. So now the question is how to run the measurement model, the first step. Measurement model is easy. We need to press on the top, you can see on the top ribbon, there is a button called calculate. Press the calculate button, a drop-down menu would appear. This drop-down menu is the first button is PLS algorithm. We need to press it. A window would appear, nothing to change in this window, just a start calculation. And once this calculation will be finished, a table or a matrix would appear in front of us. I will be coming to this table later on. Let me show you the model again. This was the model. Now this model is having certain values in between the lines, right? We need to understand what these values are. First of all, these values, right? These values, they are called outer loadings. Checking the outer loading is step number one in the measurement model analysis. These outer loadings are actually the variances, right? Like how much variance of the item is explained by the constant. Suppose this is 0.858. It means that this construct of competence explains 85.8% variance of the first question or first item of Comp 1. So definitely the variance is supposed to be on a higher side. The threshold is 0.70. It means the variance, it has to be almost 70%. So if any value is less than 0.70, it is subject to deletion. We need to delete that item, right? Let me check. 858, 798, 818, 0.879, 870, 843, 833, 917, 843, 767, 649, 0.812. I hope you all can see almost all of the values are above the threshold of 0.70, except this ATTR2, it is having a value of 0.649. Although it is subject to deletion, but I will not delete it. For the reason that if I delete it, then it would raise a question mark on my selection of items for the model or for the construct. So it's better to retain rather than delete. I'm repeating, it's better to retain rather than delete. So the latest papers, they suggest that we can retain an indicator if the value is up to 0.50. So do not go in a rush, do not hurry to delete if it is less than 0.70. Wait and see. If it is even less than 0.50, then okay, go ahead, delete. But if it is up to 0.50, it's better to retain it in the model. So I'm retaining it. I'm not opting for deleting it. For single item construct, that is CUSA, there are no outer loadings because actually 100% variance of the item is explained by the construct. These values within the circles of CUSA and CUSL, 0.295, white colored values, they are actually the values of R square, okay? R square is the variance explained. It means the comp and like together, they explain 29.5% variance of customer satisfaction. And if it is 0.569 for customer loyalty, it means competence, likability, and customer satisfaction together. All these three, they explain 56.9% variance of customer loyalty. So this is R square. R square would come at a later stage. It is a part of the structural model. In measurement model, first of all, we see these outer loadings. Once these outer loadings are all okay, then we need to check the construct reliability and construct validity. How to check the reliability? Let's see. Go to the report button, report in the indicators panel, calculation results. Go to the report button, press it. In the quality criteria at the bottom, there is a third tab, construct reliability and validity. I'm just pressing it. That's right. So here it comes. This table shows the reliability, first of all, right? There are three ways of measuring the reliability. One is Cronbach alpha. Second is ROHO A. Third one is composite reliability. And the last one is average variance extracted. Average variance extracted is actually is not for reliability. It is for measuring the conversion validity. I will come to average variance explained later on. So PLS-SEM researchers, they generally do not go for Cronbach alpha ROHO A. They opt for composite reliability for reporting the results of reliability of constructs. The threshold value is 0.70. So if these values are greater than 0.70, values of composite reliability, it means yes, constructs are reliable. Okay. So at the moment, yes, all of the values are in green and they are all are above 0.70. It means yes, reliability has been established. So I have in the measurement model, first of all, I check outer loadings. The threshold was 0.708. Then I check construct reliability with the help of composite reliability. The threshold value is 0.70 or above. Now I need to check the validity. Validity is further subdivided into two types. One is called convergent validity and the second one is called discriminant validity. Convergent validity is actually of any construct is measured with the help of this value called average variance extracted. Average variance extracted shows the convergent validity of each of the constructs used in the model. So technically speaking, all of these values are supposed to be greater than 0.5. It means yes, the conversion validity has been established. All green, it means yes, they all are greater than 0.5. So convergent validity means whether all of the items are converging to the construct or not. So convergent validity has been established. Now we are moving to the discriminant validity. So let me repeat. First of all, outer loading, then composite reliability, then convergent validity with the help of average variance extracted. And finally, the final thing in the measurement model is checking the discriminant validity. For checking the discriminant validity, we need to go back again to the quality criteria, the fourth tab, the discriminant validity. Here it is, the discriminant validity. Right? So this discriminant validity actually talks about how much well differentiated constructs are. It means constructs are supposed to be different from each other. So if they are actually different from each other, and then they are supposed to be different from each other, it means yes, construct validity is established. And if it is not established, it means actually the constructs are same, we have just changed the names, which is just not the right thing. So the threshold value is 0.85 or below. So if all of these values, if they are less than 0.85 or below, then we can say, yes, convergent validity has been established, 0.746, 0.600. For this interaction term, no need to check, right? We are checking only for the constructs of the model. This is interaction term, no need to check for it. So ATTR, COM, see, all of the values are greater except like 0.864, right? But again, we can use the leverage that that here at all 2018 it says that even if this value is greater than 0.85 and it is less than 0.90, that's okay. We can go ahead with the measurement model. This happens because some of the times, constructs overlap with each other. So if likability 0.864, fair enough, that's okay. I mean, we can ignore it, right? So these values are less than 0.85, convergent validity has been established. So measurement model is done now. Step one of the analysis is finished now. In this step one, we check 4 of the things. The first thing, outer loading. The threshold value is 0.708. Outer loadings we can check from the table as well. Here are the outer loadings, right? One is in red, it means it is less than 0.708, but we retained it. We can retain if it is greater than 0.5. Then we check reliability through composite reliability. The threshold value is 0.70 or above. Then we check convergent validity with the help of average variance extracted. The threshold is 0.50 or above. Then we checked discriminant validity with the help of heterotrait monotrait ratio. This heterotrait monotrait ratio is all having values, I mean, less than 0.85. It means yes. 0.85, less than 0.85, HTMT ratio, yes. Discriminant validity has been established. Although discriminant validity can be checked through formulaic criteria, through cross loadings, through heterotrait monotrait ratio, but we generally check through heterotrait monotrait ratio, and this HTMT ratio, if the values are less than 0.85, it means discriminant validity has been established. So measurement model is finished now. I'm moving to the last stage of the analysis called structural model. In the structural model, what do? We check the structural relationship. That is, we test the hypothesis. If I see this model, I can see it very clearly. I can sense it, and how many hypotheses have been used on it. The first hypothesis is the effect of competence, the direct effect of competence on customer loyalty. The second hypothesis is the mediating effect of customer satisfaction between competence and customer loyalty. The third hypothesis is the mediating effect of customer satisfaction between likability and customer loyalty. The fourth hypothesis is the direct effect of likability on customer loyalty. And the fifth hypothesis, the interaction effect or the moderating effect of attractiveness in between likability and customer loyalty. So once I'm seeing this model, I can sense, I can see it very clearly. There are 5 hypotheses used in this model: 2 direct, 2 indirect, and 1 moderation. So we will check it stage-wise. First of all direct effects, whether they are significant statistically or not so significant. Go to the report and see the path coefficients, right? Okay, no. I need to run the structure model with the help of bootstrapping. Okay. We need to run bootstrapping for running the structure model. Bootstrapping. I'm pressing bootstrapping. Subsamples originally by default they're 500. We need to run it on 5,000. Latest book says this needs to run on say on 10,000. But definitely the running time will increases as soon as we increase the number of subsamples. Amount of results, basic bootstrapping is by default, but we need to run it on complete bootstrapping. In advanced setting, no changes. By scripted is fine. Test type is up to you to decide whether it is 2-tail or 1-tail. If we know the direction, then it is one tail. If you do not know the direction, two tail. In behavioral sciences, generally direction is known. So I am setting it to one tail. Significance level is traditionally it is 0.05. So I'm keeping it to 0.05 and then start calculation. It will take a while. Once the result will appear, then I will show you the results of the structure model. That is the results of hypothesis testing. Yes. So it's run now. Okay. Once this process is complete, a table would appear in front of us. This is a table of path coefficients. This table would actually help us in finding out if the direct effects are significant or not. So if I see the model, there are two direct effects in it. The first direct effect is from competence to customer loyalty. The second direct effect is from likability to customer loyalty. Two direct effects. So let me go back to the model and see. Path coefficients. First of all, competence to customer loyalty. Competence to customer loyalty. Here it is, competence to customer loyalty. 0.454 is the p-value. T statistics is 0.115. Original sample is the beta coefficient. Standard deviation is the standard error. Technically, this path coefficient is not statistically significant. It means the first hypothesis is rejected or not supported. That is, competence is not having a direct effect on customer loyalty. The direct effect is there, but it is not statistically significant for the reason that the p-value is greater than 0.05 and t-stats is less than 1.645. For one-tail testing, t-stats is supposed to be greater than 1.645. For two-tail testing, t-stats is supposed to be greater than 1.96. So making it simple, if p-value is less than 0.05 and t-stats is greater than 1.96, for a one-tail testing, the hypothesis will be accepted. Otherwise, it's rejected or not supported. So at the moment, it's not supported. So first hypothesis is not supported. H1 is not supported. The second hypothesis was the effect of likability on CUSL. Here it is. P-value is less than 0.05 and T statistics is greater than 1.96. Yes, the hypothesis has been supported. I hope you can see the p-value is in green. So green is a good signal. It's a good sign. It says, yes, go ahead. The hypothesis has been supported. So out of two direct hypotheses, one is supported the effect of likability on customer loyalty, and the first one is not supported, the effect of competence on customer loyalty. Mind it is not really very necessary that all of the hypotheses are to be supported. This all depends on the data. Okay, now moving to the indirect effects, right? So in the final results, go to the specific indirect effects. It is the table of mediating effects. Mediating effects. Customer satisfaction as a mediator in between likability and customer loyalty, right? P-value is less than 0.05. T-stats is greater than 1.96. Again, the third hypothesis, the third mediating effect is supported. Customer satisfaction as a mediator in between competence and customer loyalty, yes, this hypothesis has also been supported. So two of the indirect effects and both of them are supported. In other words, both of them are accepted. So far, out of four hypotheses, three have been supported and one is non-supported by the data. Instead of writing accepted or rejected, we prefer to write supported, non-supported, because it is actually with the help of our data we are claiming whether the hypothesis is supported or not supported. Maybe with another data set, this hypothesis may prove to be true or supported, which is not supported by our data set. Now coming to the final in this model, there is one more hypothesis of moderating term, that is interaction term. This moderating term hypothesis will be checked with the help of direct effects. Again to the report column. Final results, path coefficients. Path coefficient is actually measuring all of the direct effects and moderating effect as well. In the last, we can see likability, asterisk, ATTR customer. This is the interaction term. And yes, it is 0.10. It means yes, it is supported as well. So out of 5 hypotheses, 2 direct, 2 indirect, and 1 moderation, 4 are hypotheses. 4 of the hypotheses are supported. 1 is not supported. This is the result of the structural model. And definitely, yes, majority of the hypotheses, they are supposed to be accepted or supported rather than majority are to be rejected. If majority of the hypotheses are rejected, say suppose out of 5, say 4 are rejected or 4 are non-supported, means our model is not having any statistical value at all, or it's not of any significance at all. It's a failed model. But again, it is not the case at the moment. Out of 5, 4 are supported, just 1 is non-supported. Yes, this is a good equation. This seems balanced, and we can say the structural model proves the majority of our hypotheses. So here it ends the basic analysis. Let me repeat, the basic analysis was actually divided into 2 segments. The first segment refers to measurement model. The second segment refers to the structural model. Structural model actually tests the hypothesis. This is where I am ending the seminar for today's session. Advanced analysis is also there, but definitely we will keep it to some other stage at some other time. Maybe next month sometime I will be having another workshop on advanced analysis. Thank you very much. Thank you. It's all from my side. If there are any questions, yes, I'm here to answer. Yes. Okay. Yeah.
Thank you so much for this very informative and demonstrative session. We will ask our participants to put your question in comment box. We will try to provide the answer by Dr. Syed Muhammad Fahim sir below the comments. Thank you so much all the participants for our active participation. Let me inform to all that this complete session will be available on our Research Circle YouTube channel. So if you want to watch it again or want to share it to somebody, please do visit the Research Circle YouTube channel. Thanks, and last but not the least, thank you, Dr. Syed Muhammad Fahim sir, for taking out the time for session. With our permission, I would like to end the today's session here. Thank you.
Thank you very much. Thank you very much again. Thank you again. Bye-bye. Take care.